Right. Follow the line, and then as soon as there's an obstruction, it'll stop, and it'll actually display on the screen that there's something in the way. So once you've moved it, it asks you for a button press and release. Once you press it, it carries on towards the ball. And there the touch sensor has been pressed, and it hits the ball.
So this is the outcome of our robot. We very originally called him Robert. As you can see, it includes like claw-like arms which pick up a ball, an ultrasonic sensor, which detects objects in its way and a goal, and a touch sensor.
Right, so the code of our robot includes 2 behaviours and driver class. Within the driver class, the 3 sensors are initialised, as well as the behaviour and the arbitrator within the main class. This is the code for our driver class. You can see inside the class, but outside of the main, outside of the main method, we've initialised the 3 sensors, a global variable called grab, which we'll speak more about in a minute, and a different pilot, which we'll also speak more about in a minute. The reason we did this is because it stops us from having to repeat code because these are used in multiple behaviours. Within the main method, then you see the 2 behaviours initialised, as well as the arbitrator, and then the arbitrator started. And then, as I said, we also have a differential pilot. This is so that we can rotate the robot from side to side without having to individually write code for each motor attached to a wheel. Here you see it's initialised as static, so it can be used outside of the main method, but in multiple classes. Uses motor A and motor C, the outside 2, because there's one attached to wheels, and then the 2 integers there, 60 and 60, are the wheel diameter and the axle length.
Okay, so we have a touch sensor. We used like a lever type structure, which just gave the touch sensor more surface area. Because obviously, usually it's quite small and it could maybe avoid the ball if we didn't use a lever. So as you can see here, we use an if statement. So if the button is pressed, the motor B, which controls the claws, rotates minus 130 degrees at a speed of 70. This was basically a trial and error. We got this working. Unlike everything on our robot, this always does work. This does work really well all the time. So once it's grabbed the ball, as you saw just then, it waits for a press and release. Actually, it reverses slightly before, I don't know if you saw that, so for us to remove the stand of the ball and then waits for a press and release. And once it's been grabbed, using the grab++, it records this, which was important, as you'll see later.
Okay, so the light sensor is the most important sensor on our robot. It's at the bottom of the robot so that it can detect what surface is underneath. If it's over a black line, then it will just travel forward, whereas if it's over a white surface behind the black line, it will tell the robot that it needs to turn to get back onto the black line. The code for this forms the majority of our trundle behaviour, which is the most important one by far. Have a look at the code in there. You can see that we make this integer the black-white threshold and then test whether the light value is greater than this or not, obviously because with a light sensor the higher the number, the brighter it is. So if it's more than 45, then it'll be over a white surface and it will tell the driver that it needs to turn left to get back onto the track.
Okay, so we also have the ultrasonic sensor, which either detects if an obstacle is in its way or the goal is in its way. So if it's an object, we know that it's an object because there hasn't been anything grabbed yet. So in this case, there's a message displayed on the screen and it waits for the press and release. If the grab has been recorded, it knows to release the arms and release it into the goal. Yeah, so as you can see there, we use an if statement and an else statement. If it's not equal to 0, so if it's not 1, and therefore it hasn't picked anything up, it releases it into the goal and shows goal on the screen, just for aesthetics, and then sleeps so the user can read this. And if not, it displays something in the way and waits for a press and release.
We did have some problems and things that we thought that we could improve if we had more time or did it again. The first problem we encountered was trying to add a listener to one of the classes. We tried this with a sound sensor, and we also tried it with the touch and ultrasonic sensors that we have at the moment. but we found that it detrimentally affected our code by adding a listener, so we left it as behaviours. And then that's why we added the grab, was because when the robot hadn't picked up a ball, it would still run the motor B. It would try and turn negative 130 degrees again, which would actually cause the motor to continue turning until it broke the front end of our robot. So that's why we had to add there's something in the way action. And yeah, as we said, we could have put the touch sensor, the grab action, as another behaviour if we had had more time. As you can see there, it stops. It's not the best quality, but it actually says on the screen there's something in the way. So you move it out of the way, press the enter button, and it continues along the line. Again, there it prints that it's picked something up on the screen. Press the enter button again, and it will continue to follow the line. And then once it finds the goal, release it and end the program. Good.